like to welcome everyone to the 2016 Computer Network Information Technology Capstone Presentation. We're really glad that everyone came to these presentations, and I hope you enjoyed them all. So the first presentation will be going over implementing network function virtualization on a carrier Ethernet network. My name is Brian Wolf. I'm the team lead and also lead network engineer.
I'm Colin Ivey, and I'm the security engineer.
My name is Jim Andrew, and I was one of the NFE engineers.
And I'm Matt Schneider, and I was the other NFE engineer.
So our sponsors for this project were Wisconsin Independent Network, also known as WIN, and Telco System. On our team from WIN, we have Jason Hodacek, Kevin Bryant, and Glenn Rader. On our team from Telco Systems, we have Dion DeChev and David Lee. So our agenda today, we're going to be going over, first starting with the problem statement, as given to us by WIN. Then we'll give you guys a brief overview of what network function virtualization is and what it does. Then we'll give you the implementation WIN will use for their infrastructure. Then we'll go over our lab environment, show you guys a demo of everything working, and then we'll go over our conclusion and our thoughts and any questions afterwards.
So the problem statement that was given to us in the statement of work was to explore the feasibility of implementing network function virtualization on WIN's network using telco system devices. And all of this was in order to broaden the services that WIN can offer to their customers and shareholders. The deliverables for this project will be a proof of concept demo, an intrusion vulnerability testing done by the WIN team, a formal white paper, and this final presentation. So what is NFV, or Network Function Virtualization? Well, simply put, NFV is taking your physical networking devices and virtualizing it on a server. If you wanted to deploy a new router, or maybe a switch, or even a firewall, all you need to do is obtain a license and OS image and deploy this network function on a hypervisor. These instances that you deploy on your hypervisor are called VNF, or the virtual network function, not to be confused with NFV. So what does this actually mean for your organization? Well, NFV offers a streamlined deployment process of these network functions, as well as offering ease of configuration and management. We'll touch on these later in the presentation. So you may have heard of this new technology called software-defined networking. In this project, we didn't touch software-defined networking at all, but I want to talk about it today because people can often confuse SDN and NFV to be the same thing. However, this is not the case. While the two are very similar and often implemented on the same network, the two have different goals in mind. If you look at the topology here, both are fairly similar. Both have a connection to the ISP, a demarcation device on your WAN edge, an access layer, and then a controller for each of the two technologies, an SDN controller or an NFV controller. It's how these controllers interact with the rest of the network that makes them different. So what SDN does is it actually separates your data and control plane on your network, meaning that it can control the flow of a packet on your network going from point A to point B. Think of the SDN controller as the brain of your network functions. What it actually does is it does the processing for the network functions and can deploy new virtual instances or resolve network congestion. NFV, however, the controller, basically just manages all your virtual network functions. It doesn't worry about the flow of the network except the traffic going through the virtual machines. The virtual machines are identical to their physical counterparts except for this, how the traffic needs to flow through the virtual machine. The reason SDN and NFV work together so closely is because they complement each other so well. The SDN controller can actually reach out to the NFV controller and deploy new instances in case of device failure or network congestion. So now that we know a little bit more about NFV, we can go into the goals of NFV for your organization. First one being a reduced capital expenditure. If you have devices going end of life or equipment upgrades needed to be done, you can either buy a physical device that's going to cost 10 times the price of a virtual machine, and you might be able to upgrade it every few months or so, but really it's going to last you about 3 to 4 years. If you purchase a license of a virtual VNF, this is going to last you a lot longer and be a fraction of the price. Second goal of NFV is a reduced operational expenditure. When you're spending less time configuring physical devices, if you figure purchasing, receiving, configuring, and finally deploying it, the amount of time that it takes to deploy a virtual instance is a fraction maybe a day compared to several weeks to a month. And finally, the third goal of NFV is a reduced footprint of your data center. When you virtualize these network functions, much like virtual servers, any virtualized server, you're reducing the amount of hardware that you have in your data center. This obviously leads to less power, space, and cooling needs for your data center, saving you money over time.
So I know we just hit you with a lot of information in a fairly short amount of time. So I'll give you a brief recap of what we've talked about so far. We've gone over what exactly NFV is. We've discussed the differences as well as the similarities between NFV and SDN. And most recently, we've talked about the goals of NFV. So maybe you're asking yourselves now, well, why would an organization want to implement NFV on their network? The answer is really pretty simple. The IT industry, as many of you may know, is becoming more virtual every single day. 60 to 70% of all servers in the industry are virtual. So let's say we take this one step further. Let's virtualize our routers, our firewalls, load balancers, as well as many other network functions. That is exactly what NFV is doing for us. Even some of the major vendors in the industry, such as Cisco or McAfee, both have developed virtual operating systems. And there are many other vendors in the industry which are doing the exact same thing. And finally, let's say we want to roll out a brand new router on our network. Physical router. This could take hours, perhaps days, when you consider finding a place for it, racking it, attaching all your cables to it, and consoling in and doing any configurations. With NFV, it could be a few clicks, and literally minutes later, you could have yourself a brand new virtual router ready for production use. So this prompted us to ask the question, well, why would Win want to implement NFV on their network? Well, being that NFV is virtualizing network devices, this would greatly expand the opportunities of services that Win could offer to their customers. In turn, those customers would then be able to enjoy all of the benefits of NFV. That being what Colin touched on recently, reduced operating expenditures, reduced capital expenditures, as well as reduced footprint in the data center, being that that physical hardware is no longer there. I would like to point out here, however, that the customer, if they so desire, is still able to manage those virtual devices. It doesn't necessarily have to be Win's duty now to manage those devices. And finally, this would offer Win a huge competitive advantage, being that they could potentially be one of the only, if not the only, ISP in the area offering NFV services to their customers. So now let's take a little bit more of a visual approach as to how NFV works, or how Win could implement NFV for their customers. So what we have here is Win, an ISP, offering an internet service to their customer. On the customer side resides a physical router, as well as a physical firewall. With NFV, you could virtualize these devices. In turn, you would then need some kind of essential management software. For our project, we used Telco's Edge Genie Orchestrator. And now Matt will go into a little bit more detail on what Edge Genie Orchestrator can do and what it is.
So like Jim was just saying, Edge Genie Orchestrator is the main central management software that we used for all of our network function virtualization systems. It works very well with both SDN and NFV, and works great for all of the management and updates and configuration of all of those systems in one central software. Another part of this program that we used very extensively in this project is the integrated NFV orchestration GUI. And this is what allowed us to configure and deploy each of the individual VNF instances that we used in this project. So we actually used Edge Genie Orchestrator to manage as many devices as we could, just so that we could get the full effect of how it worked and what all we were able to use it for. So we were able to put it on 4 of the 5 devices in this picture, the top 4. And here I'm going to connect just a name with a picture as to what each of the devices is. And then in the next few slides I'm going to go into a little more detail what each of them is and how they work. So the top two devices are the Telco Systems Cloud Metro 100s. Below this is the T-Mark 3348S. Below this is the T-Metro 7124S. And on the bottom we have an ESXi server running all of our extra server duties. Now the Telco Systems Cloud Metro 100 was really the heart and soul of this project. It is what allowed us to host all of our individual VNF instances, and is a brand new device coming straight from Telco Systems, so it was super cool to get to work with something totally new. This is a hybrid device. The left side of it is a 10 gig switch with several 10 gig compatible ports, and then the right side of the device is an Intel x86 based server that actually hosts each of the individual VNF instances and runs them right off of the device. This device would normally be placed at the customer location. And that's one thing that's really cool about this specific device, is that in the past you could take the virtual network functions and you could install them on a normal hypervisor or a normal server, but usually that server is at a data center and that's not actually at your physical location. But if you're trying to virtualize things like security functions or trying to run WAN optimization or something like that on that network, it doesn't work very well to have these functions to be at the data center. It works a whole lot better to have them at the customer location. So this device is super beneficial in that area because it allows you to bring that security and the WAN optimization right into the customer's LAN. Next two devices are the 3348S and 7124S. These are devices that a company like Win would use to transport the internet service to the customer. These also are both managed by Edge Genie Orchestrator. The 3348S is a remote demarcation device that would be placed geographically fairly close to the customer, and the 7124S is a main distribution device that would be placed either at a distribution site or a data center or something like that. Both of these devices are available in several different configurations and sizes depending on the needs of both the ISP and the customers.
Alright, so now that Matt has gone over the hardware and software used, I'm going to quickly go over our lab topology so you can understand how we had it all interconnected, and also so you can understand our demo that will be going over here shortly. So here's our lab topology. First thing I want to point out here is this pfSense virtual machine that we have running here. This acted as default gateway for our management network. So all the devices on our management network could go out to the internet, get some updates if they need to. And also acted as a main point for our VPN. So we don't have to sit in a really noisy, loud capstone room. We can be going from anywhere to manage the system. The second interconnection we have here, we utilize this to push forward to any of the VNFs we created that would be on the Cloud Metro 100s. So we could actually test the VNFs versus a live internet connection. We actually gave them public-facing IP addresses and then ran security and vulnerability testing against them. Next thing I want to point out is our Edge Genie server here. So like Matt said, this is the central location for all the management of everything. And this is actually running on an Ubuntu desktop, and then the application is just installed on top of that. The last thing I want to point out is the Windows 10 machine here that's connected into the Cloud Metro. We use this for customer-side testing, so we can actually verify that VNF is configured correctly, giving out DHCP, DNS, and then the customer can get out to the internet. Alright, so that leads us into our demo. So what we're going to do for our demo is pretend that we are Win. We received an order from a customer that's interested in our new NFV server that our NFV setup that we have. And so we're going to get an order form, we're going to fulfill the order using a couple steps, and then at the end we'll show you a working network from the VNF on the customer side. So here's the service request form. As you can see, our customer is UW Stout. They want to change their service. Currently I have a 10 megabit per second service, which I think is pretty slow for UW Stout, but we'll go with it. Important thing to note here is that it is managed. So Win will be doing the management for this device, and also be utilizing the Telco Systems Cloud Metro 100. Another thing that's not on here is that UW Stout has also requested a Fortinet router. This is just a variation of a router you can get online, and it's virtual. So now the steps. So the first step we're going to go through is actually tell the internet service that UW Stout has that it needs to route through this VNF before actually going out to the customer. We're then going to create the networks the VNF uses to communicate with the service and the customer. Then we're going to deploy the VNF, which do some quick configuration on it, and then show you a working network. So like I said, the first step is attaching the VNF to the service. So currently, UV setup looks something like this. They have an internet connection that runs over WIN's network and then gets to them. So in this step, what I'm going to be doing is telling this internet connection to actually run through the Fortinet VNF before going out to the customer. So to demonstrate this, you guys look at the right screen. You can see this is the telco orchestrator GUI that we were talking about before. So this is the central management location, like Matt was saying. You're first greeted with the executive summary, gives you a brief live update of everything. The view I really liked the most was this domain topology view. And this automatically updates if any of the devices are down or if something's unplugged. We actually had a cable that didn't have a clip on it, so every few weeks it would just work its way out of the port and unplug itself. And then we would see that because this line here would be red. So what I'm going to do here, I'll show you the service we have created for UV Stoke. Here it is. It's running through 7124S, that internet connection I was talking about earlier, and goes out to Cloud Metro. So what I'm going to do is tell this service that it needs to run through the VNF first. So I click on VNF service here. Enter in the VLAN here, 210. I'll hit compute. So I can clear this out from last time we practiced this. Then I would hit update, and it would actually update the service to tell it that it needs to run through that VNF first. So now that I'm done attaching the VNF to the service, Jim will take over and creating the networks.
So as Brandon just said, the next step would be to create the networks. For time's sake, we've actually already gone in and created those networks, but I can still go in to our NFV orchestration here and show you what exactly is going on. So I'm just going to click on this NFV orchestration here.
So what this is the web interface for what Matt was explaining earlier, the second part to the telco orchestration. This is where we actually do all the deployment of the VNFs, creation, configuration, and also deletion of them. It might look familiar to a lot of you because it is running on top of OpenStack.
Thanks, Brandon. So now I'll click on this network topology here. What we have here, this is VLAN 4091. This would be the management VLAN. This is what we use to remotely manage our devices. In WIN's case, this would also be the VLAN that they would use to remotely manage devices. We have a VLAN 210 right here, as well as VLAN 100. And in this next slide here, I'll show you a little bit more detail what exactly is actually happening there. So what we have here, and that larger light blue box is actually representing the Telco Systems Cloud Metro 100. And in that bottom left, you can see that service there that Brandon just modified for us. Well, what's happening here is this service will run through the Cloud Metro 100. And as Brandon stated, we are modifying the service to be routed through that Fortinet VNF. It will exit out the port as an untagged packet, finally reaching the customer. And I will hand it off here to Colin and he will go through deploying that VNF.
So now that we actually have the network to deploy the virtual instance on, we can go through the steps to attach that or deploy that instance to those networks. There's 3 steps in doing this. The first 2 steps are actually only needed to be done once, so we have already done this in the interest of time. That first step being creating the image. What this means is you're just uploading an image file to the NFV orchestration to be deployed at a later time. And the image source, saying image file, just means we're uploading a local file that we have on our computer. Next, we would create the flavor. What the flavor is it's a hardware requirement template. Since we're doing the Fortinet, we were pretty limited to what we could use for our hardware on this device. So 1 virtual CPU, a gig of RAM, and a 40 gigabyte hard drive. And finally, we can actually go in and launch this instance using these settings here. So we'll be back in network topology here. You see the networks that Jim has created, and we'll just hit launch instance. And once this dialog box opens, we can enter in this configuration. Availability zone is just selecting which Cloud Metro you want to deploy this instance on. So in this case, we're going to use 1008, which is our Cloud Metro 1 device. Instance name will just be Fortinet Demo. The flavor, referencing the second step up there, we're going to select the Fort iOS eval. And that's just automatically going to set the hardware requirement details over here on the right. And then the boot source, again, going from step 1, we'll select boot from image that we uploaded earlier and select the Fortinet image. So then we can go over to the Access and Security tab and select the default security groups. What this is just selecting who you want to be able to access this VNF. So we're just going to use default for this demo. And then networking. These are the networks that Jim has created. So we're going to select these here and add them. And it actually matters which order you select these in. The order that they're selected in is actually the order that they're deployed and configured on your virtual instance once it has completed. So your this management 4091 here will be configured on the first available interface on the Fortinet device. Post creation is just if you want to add a script for scripting any initial configuration. We're not going to do that for this demo. And then advanced, we're just going to do automatic disk partitioning. So then we'll hit launch. And Fortinet is a rather small OS, so it should just take a couple seconds here. You can see it's currently in the build status. And there we are, active, and now it is ready to configure.
Alright, so now that Colin just deployed the VNF, there are some initial configuration steps that have to be done for the network settings of that device so that it can communicate with the network the ways that it needs to. So I can just click on Open Console here. And these are the steps that I'm going to enter in. The just general network commands. So here I can log in, and it will just be the default login. For the interest of time, we actually already have this all done. Just it's boring watching me type in commands. So if I go down to the other Fortinet instance that we have here, this one is at the next spot. These commands have been entered in already, and it is at its ready to go stage, ready to be configured. So the IP address of this one here is actually 10.0.0.40. And you can see that then it brings up the Fortinet login page here. And if I go to the networking tab and then interfaces, you can see, like Colin was saying before, that they got applied to the device in the order that he added them in as he was launching the instance. So the management is port 1, and then the WAN is port 2, and the WAN is port 3, based off of how he launched that instance. So if I go to back to the dashboard here, I can show you that this is actually working. So I can execute a trace route back out to Google's server. You can see that it actually travels over the real network rather than making it out our management network or something weird like that. So this is configured and ready to go the way that it needs to be.
So that's our last step, and we have a working network. So you can see how this could be really flexible for when, say a customer approaches them and they actually run Cisco gear. Win could give them this cloud metro and then deploy a Cisco router on top of them. Or if it was a Brocade, they could deploy a Brocade router on top of it. And this just expands the services they can offer to them. So that kind of wraps up everything. Just want to kind of go over project hours. We had 477.5 hours in total working on this over the semester. So we average about 10 hours per person per week working on this. As you can see, there's a little slight nothing happening week 9. That was spring break when we were studying other classes. And then you can see it kind of goes up quite a bit in the last couple weeks there, and we're just finishing up the project, getting ready for this presentation and white paper. All right, so before we, oh yeah, sorry. So for me, I actually last week this happened to me. I learned that you always make backups before doing anything. Because the Edge Genie server that we have set up decided, hey, let's do some updates. Updates are always good. I did updates to it, restarted it, and then our Edge Genie login page usually looks like this, and instead it looked like this. So OpenStack completely wrote over the configuration and everything on that. So I was freaking out because this is last week. I figured we're going to be here today, not be able to show anything. Luckily, the installer actually kind of has a backup feature built into it. So if you have an existing installation, I'll back that up and then push the configuration towards the new one. So I got extremely lucky there that I didn't have to rebuild completely everything. So that was, terrifying that night. But yeah, so I figured that out. And we're working good now.
One of the lessons I learned was to not be afraid to ask questions. Kind of early on in the project, we hit a wall with configuration. We weren't really sure where to go with the project. So we reached out to Dayon at Telco, and he was able to sit down with us for close to 3 hours and just give us a demo of everything, how it all worked, what we needed to do to get it deployed. And it really helped us figure out where we needed to go from there with the project. So then, I guess on top of that, just using Telco system devices. In the ITM program, we're usually restricted to Cisco and Microsoft, which isn't a bad thing, but definitely don't get to reach out to different technologies. So it was nice getting our feet wet with Telco or other besides Cisco and Microsoft.
One of the big lessons I learned was in our industry, information technology, we are going to constantly be exposed to new technologies all the time. And I learned you just really gotta embrace it. You can't be afraid. I remember that very first day of Capstone. I was already nervous. Then I read our statement of work, and I was more or less terrified over what the next 3 months would bring. I had only the slightest idea of what software-defined networking was, and I had absolutely never heard of NFV. Fast forward 3 months later, and I have a much better grasp of SDN, and it was actually a lot of fun and very interesting learning about NFV.
One of the biggest lessons that I learned was just building up professional communication skills. It was really cool to get to step out of the classroom setting and get to work with multiple industry partners on this project. And like, hey, we need to get a hold of somebody through email communication, or we need to set up a WebEx meeting for something, or just all of that stuff that we'll use on a daily basis out in the real world that we haven't really done much because we walk up to the class and we talk to everybody. So that was super valuable to get to develop those skills.
All right, so before we wrap up, I just want to give out a bunch of thank yous. Definitely to our two sponsors, Wisconsin Independent Network and Telco Systems. You guys are awesome. You're always there to take time out of your busy schedules to meet with us, to reply to emails, and help us along the way. I'd also like to thank you, Restart, for having this capstone program. It's really awesome that we can work with real life companies and get experience for the future. I'd like to especially thank Holly Jan for all the time and effort she puts into this. She does a lot of work actually getting the sponsors for us for each of our projects and helping us along the way. And then I'd like to thank you guys, the advisory board, for being here today and listening to our presentation and hopefully enjoying it. And yeah, so any questions?
Actually, sure. What's the underlying hypervisor on the Telco box?
Runs, I think it was a Ubuntu installation. I don't exactly remember what version.
14.04.
Was it? Yeah, so that's just underlying Ubuntu. Yes?
Are there performance implications of virtualizing these things, which we typically have hardware for that's dedicated to these operations?
I would say definitely you might notice something, but virtualization has come a long ways from when we first started virtualizing servers. I mean, the main reason you virtualize is to conserve hardware. Nothing's going to use full 100% of its hardware all the time. So virtualizing, you be able to conserve this hardware and spread it out between multiple devices. We did a little bit of testing on throughput DNS, and we had a gigabyte connection to use, and we didn't notice really any slowdown with it. And I mean, we didn't test it completely, but we definitely didn't notice anything. Anything else? All right. Well, thank you guys.